Imagine the entire universe squeezed into a space smaller than a pinhead. It's almost impossible to fathom, but this is the starting point of everything we know. That's what the Big Bang Theory describes. A moment of unimaginable density and heat, followed by a colossal expansion. It's the idea that our universe began from an extremely hot and dense state, then rapidly expanded and cooled over billions of years to form everything we see today. This process transformed the universe from a chaotic, fiery state into a structured cosmos filled with galaxies, stars, and planets. This theory isn't about an explosion in space, but rather the expansion of space itself. Space itself was stretching, carrying galaxies with it like raisins in a rising loaf of bread. It's like blowing up a balloon. As you inflate it, every point on the surface moves away from every other point. This analogy helps us visualize how space itself expands, making distances between objects grow over time. The Big Bang happened everywhere at once about 13.8 billion years ago. It wasn't a localized explosion, but a simultaneous event that set the entire universe into motion. It marks the beginning of time and space as we know them. Before this event, the concepts of time and space as we understand them didn't exist. Everything around us, from the tiniest atom to the largest galaxy, originated from this single event. The Big Bang set the stage for the formation of matter, leading to the complex and diverse universe we inhabit today. In the first fraction of a second after the Big Bang, the universe was unimaginably hot and dense. It was a chaotic soup of energy and fundamental particles. As the universe expanded, it cooled down rapidly. This allowed for the formation of the first protons and neutrons, the building blocks of atoms. Within the first 3 minutes, these protons and neutrons started to combine, forming the nuclei of the lightest elements, hydrogen and helium. This process, known as Big Bang nucleosynthesis, is responsible for the abundance of these elements in the universe today. About 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Before this, free electrons scattered light, making the universe opaque. With atoms forming, the universe became transparent, and light could finally travel freely. This first light, released as the universe cooled, is still detectable today. We call it the cosmic microwave background radiation, or CMB. It's like a faint afterglow of the Big Bang, providing a snapshot of the early universe. The CMB reveals tiny temperature fluctuations, which are the seeds of the large-scale structures we see in the universe today, like galaxies and galaxy clusters. Section 4. From gas clouds to galaxies, building blocks of the cosmos. The universe is a vast and mysterious place, filled with wonders that boggle the mind and stretch the imagination. Over millions of years, gravity pulled together the clumps of matter in the early universe. These gas clouds, composed primarily of hydrogen and helium, began to coalesce under the force of gravity, forming denser regions. These clumps grew denser and hotter, eventually forming the first stars and galaxies. The birth of these celestial bodies marked the beginning of a new era in the cosmos, lighting up the universe for the first time. Stars are giant balls of hot gas that produce light and heat through nuclear fusion in their cores. This process converts hydrogen into helium, releasing immense amounts of energy that we perceive as starlight. They are the factories that create heavier elements beyond hydrogen and helium. Through nuclear fusion, stars forge elements like carbon, oxygen, and iron, which are essential for life as we know it. When stars die, they expel these heavier elements into space, enriching the material from which new stars and planets form. This dramatic end often comes in the form of a supernova, a powerful explosion that scatters the stars' enriched guts across the cosmos. Our own sun and solar system, including Earth, formed from such enriched material about 4.6 billion years ago. This cosmic recycling process has been ongoing, creating the diverse and complex universe we observe today. Section 5. Cosmic Pioneers, the minds behind the Big Bang. The Big Bang Theory didn't just appear overnight. It is the culmination of centuries of astronomical observations and theoretical advancements. It was developed through decades of observations and theoretical work by many brilliant scientists, each building upon the discoveries of their predecessors. Edwin Hubble's observations in the 1920s showed that galaxies are moving away from us, implying an expanding universe. This was a groundbreaking revelation that changed our understanding of the cosmos. This provided the first observational evidence for the Big Bang, suggesting that the universe had a beginning and has been expanding ever since. George Gamow and Ralph Alford developed the theory of Big Bang nucleosynthesis, explaining the abundance of light elements in the universe. Their work showed how the first elements were formed in the early moments after the Big Bang. Arno, Penzias, and Robert Wilson accidentally discovered the cosmic microwave background radiation in 1964, providing strong support for the Big Bang theory. This faint glow of radiation is a remnant from the early universe, offering a snapshot of its infancy. These are just a few of the many scientists who have made significant contributions to our understanding of the universe's origins. Their collective efforts have helped us piece together the story of how our universe came to be, from the initial explosion to the vast cosmos we observe today.